Good morning, good afternoon, and good evening, everyone. We start with the session. Can you all please give me a quick information if you all can see my screen and hear me loud and clear as well? Great. Thank you for the confirmation, everyone. So now we are going to start a discussion on DevOps, where we are going to first of all discuss on why DevOps, what exactly it is, and different tools and lifecycle available in DevOps. And then we are going to discuss on the hands-on on top of DevOps as well. All right, so first of all, if we talk about DevOps, then DevOps is like it's like a complete software development lifecycle model that we follow nowadays to ensure that we are having a smoother delivery, smoother and continuous delivery of the applications, and that too by using all the all the major platforms that are used by developers, so that we don't have to worry about the manual deployment of the codes and whenever we are working with a large scale application. That is what we do by using DevOps. So if we talk about the earlier models of software development lifecycle that we refer as SCLC, then earlier we used to have waterfall. So waterfall was really good for a small scale project, but again, it was not good for large scale project, because on the waterfall we had a fixed timeline, we have a fixed structure, and this was suitable for those projects where we didn't have any kind of, or we can say any kind of custom development, or we can say we didn't have, we can say frequent changes that need to be that was needed to be implemented. So when we don't have much changes, we have a fixed structure, we have a small scale application that needs to be deployed. So there we can make use of this waterfall model. But again, as the application required a frequent change, and plus we also needed to make sure that again the changes are being implemented as soon as possible. So there, this model failed. And then we had, again, that's why we can see here we have these traditional models, like we have requirement, design, implementation, test, deploy, maintenance. So these are for the conventional platforms. But again, we cannot go back from one stage to the previous stage. If we want to go back, then we have to wait for the entire stage to be completed, then only we can go back. That's how it was structured. And that's why, because of these different, we can say, limitations, as we have discussed, these are not good for the complex projects. That's why because of these different limitations, that's why we came up with something called as Agile as the updated, and we can say a better version to solve those issues. So Agile simply made it easier for us to iterate the process of development, design, and discover. So we can play around with the entire, we can divide the entire project into smaller components where we can continuously design, develop, and again make sure that again the entire solution is designed as per the requirement. But again, still there was no continuous delivery. The delivery was done towards the end itself. So it solved some issues, but again, not all of waterfall. And that's where we had a requirement of DevOps. So DevOps, the main advantage of DevOps is to have that continuity. So we can understand that in simple layman terms. Let's say here we have two teams. We have developers and then we have operations team. Now developers team, they are done with working on the code. For example, they have worked on the Python application code, and that Python application, or suppose Java application has been developed on top of JDK 8, and the operations team is running JDK 7. So for the developers, the code is working fine without any issues, whereas for the operations team, the code is not running fine. So if the developer sends a code to the operations team, they will say the code is broken, and when at the developer they are going to test the same code, they will find no issues in that, and this creates a civil war between these two. And that's why, to bridge this gap, to make sure that these things are not one of the main pain pointers for the entire development process, that's why we include DevOps as a life cycle. So DevOps is made of two different terms, development and operations. So it simply bridges the gap between these two. So what exactly DevOps is? So if you talk about DevOps definitions, again, DevOps is like a complete development lifecycle through which we can automate the process of fetching the code, creating a build, and deploying it on the servers, and also working on a continuous monitoring on those different solutions, so that whenever there are any issues or any feedback that needs to be passed on to developers, that can be done as quickly as possible. So we have different stages available in DevOps, starting with the planning phase. Then we have coding, building, testing, integration, deployment, operations, and monitor. So first of all, we start with the planning phase. So for planning, we have tools like we have Trello, we have Jira. So again, these platforms allow us to ensure that we are planning the entire solution and that in a most efficient format possible. And then if we have like it so that the entire process of development, that means which all tools will be used and how the solution design is going to be developed and implemented. So these all things can be strategized, and all the team members, they can be on the same page before the project starts. And then after this, we are going to move on to the coding phase, where we use tools like we have Git. So Git is one of the version control systems. So we have something called as VCS, as in version control system. So version control system means if we have been making continuous changes on the application code, so there we need to make sure that we are going to track the changes, so that in case there are any changes done on the code, for example, we have made 20 different changes, so we can quickly revert to any of the previous change as and when required. We don't have to worry about doing the same thing again and again, and we can track the changes done by us and also by other team members as and when required. So that is what we do by using the version control system. So Git is a part of distributed version control system, and we have other tools like we have SVN. So SVN is like a centralized version control system that we have, or we can make use of Git as well. So these are the platforms we use for making sure that we are having a complete coding structure. We are able to track all the versions, and then we also have something called as a remote repository, like we have GitHub, through which we can push our code that is going to be available to other developers, and they can easily pull the code as and when required. So that is what we do by using these version control system as a part of the code building stage. And after the code has been built, after it has been tracked and well documented, then we move on to the building phase. So when we are done with the application, we are when we are done with the application, we have to create a build. For example, if we talk about the Java application, so before we can deploy Java application, we have to build that Java application, right? And that can be done by using multiple build tools like we have Maven, Gradle, SonarQube. So in case that kind of build is required, we can go ahead and pass this code to the build stage here, where a build from a predefined script running on a given tool can be used for creating a build out of it. And once the build is available, we have to attach a testing script to it as well. For example, let's say if you talk about Selenium, JUnit, QUnit, so these are different testing platforms. So using these platforms, we can test if the functionality is as per the expectations or not. So again, basically here we have to create a testing script, and that testing script is what we have to attach to the code that has been built, so that the test results can be obtained and it can be visualized in a dashboard automatically. And then we have in the center, we have integration. So integration is the core of DevOps. So that's why we can see it is placed as a core. So integration means automating everything here, integrating each and every steps. So when we say integration, then we have multiple tools like we have Hudson, Bamboo, Jenkins. So these tools are used for creating a pipeline. So when we say a pipeline, that means we would be able to automate each and every process that there is. For example, if we go back to the annotation mode, so pipeline means here we would be able to design a pipeline. Just a moment. So in this pipeline, suppose here first of all we want that we have multiple developers. For example, we have multiple developers as developer 1, developer 2, developer 3. They may be working remotely from remote location, and they all are working on the same application, and they are submitting their code in a centralized repository like we have GitHub. So they can either, if for example they are using any of the cloud vendors, they can use the repository from those cloud vendors, for example for AWS or for Azure, or we can make use of GitHub. So again, developer 1, developer 2, they all are working on the same code, and they are pushing the code to this repository. Now we want to create a pipeline in the integration platform, like we have Jenkins, we have Bamboo. So what we mean by that pipeline? So let's say developer one has pushed a code, developer one has done adding a functionality. So we want that as soon as a new code has been pushed to this repository, that code should be automatically pulled from the by the integration server here. So we can say the code should be automatically pulled, and then a build out of it should be also created automatically. So what kind of tools we have to use, how the build has to be created, the entire script, that is what we can define and save it, and that build will be automatically created from the code which has been pulled by the pipeline, by this integration server. And then we can, if you want, we can even attach a testing script that we may have deployed on by using any of the platforms. And then we can define in terms of deployment, we can deploy it either in the testing environment or on the staging servers or even on the production servers, depending upon which branch of code we want to push in which all environment. So this entire automation of each and every progress, yeah. So again, either feedback. For example, if there's a feedback by our developers or by the end users on this code, then even those feedback can be sent directly to the developers so that they can work on the feedback, and then they can go ahead and reshare new package with the improvised performance and bug fixes. So this entire process of automating is done by using the integration platform, and that is what we mean by continuous integration. And here we have multiple platforms to help us in that, like we have Bamboo, Hudson, and Jenkins, and then we have multiple deployment platforms, like we have deployment, so we can deploy the application on top of the virtualization, or you can say containerization platform, like we have Docker, Vagrant. So when we say containerization, that means we have to simply create a container that can automate the process of deployment. For example, we don't want to deploy complete VM because VM includes the host image, the host OS. So we don't want to include the host OS. We only want to package the application and all the bins and libraries that are required to run that application. So we can package them in a single container, and then we can run them in a containerized environment so that only those dependencies will be included, and the entire deployment becomes really fast and much more efficient as well. And then for managing all the containers and all the other, we can say, deployment containers or servers that we have here, we can make use of tools like we have Chef, Puppet, Ansible for the configuration management. If you want to apply any kind of configuration changes here, so we can do that easily by using these tools. And then once we are done, so we have to monitor all the resources. So monitoring is something that can be easily managed by using tools like we have Splunk, Nagios, Slack, or we have other platforms like we have Prometheus, Grafana, and then we have multiple other solutions offered by the cloud platforms as well that we can make use of. So that is what we can set up by using a complete DevOps pipeline. So now after this, we have the DevOps tools and stages. So as we discussed, first of all, we start with the version control, and then we have, and for version control, we can make use of platforms like we have Git as a part of distributed version control. And then we have the continuous integration tool through which we can build continuously from pulling the code automatically from the build servers. And then we have discussed, we have we have services like we have continuous delivery, and using the continuous delivery part, we can go ahead and deploy the servers on any of the continuous platforms. And then we have continuous deployment, where we can make use of tools like we had Docker, that we have Vagrant, and so on. And then we have discussed on the concept of source code management tool, like we have the version control system. So in here we have a version control system available here. So what happens? So basically here in the centralized, but we have two different types. We have centralized, and then we have distributed version control system. Now under centralized, we have all the working copy as in the workstations of different developers. Once they are done working on any file, they can directly commit those files. Commit as in they can update, they can push those files to the centralized repository. But again, in here, if the centralized repository is not available, then the code is not going to be pushed. It is going to be broken. And then here we have the distributed version control system. So here we have something called as local repository. So this local repository can be either on the same system as developer system, or they can be available in a centralized location like we have for Office. So if we are done with it, when we are done with the code, when our developers they are done with the code, so they simply push the code to a local repository. So even if the remote repository is not available, still the code can be saved in the local repository, which can be pushed later on to the remote repositories as well. We can easily do that. And that is how, again, and that's why we have main tools that we have Git. So Git is a distributed version control system where we can have a working directory where we are going to, now to start tracking the changes, we have to use something called as Git Add. So using Git Add, we add the files to the staging area, and then once we are done tracking the files, and we move those files in staging area to local repository once we are done working on the code. And then from the local repository, it gets moved to the remote repository. That's how they are structured. So now we are going to discuss on how we can set it even further. So in terms of the continuous integration, we have discussed different developers, they can work on submitting the code to a centralized repository that can be pulled by a Jenkins server, and a build out of it can be created. When we say build, that means it can be, the entire code can be compiled, the code can be reviewed, the unit testing, integration testing can be performed, and then the package, as in the var or jar package, can be validated. And then in terms of the deployment, so again, the code is going to be automatically deployed to the we can say to the build or to the testing servers, staging servers, production servers as per the setup required. And then we have the configuration management tool. For a simple example is, let's say we have a cluster of 100 VMs that needs, and again, they all are running LAMP servers. So now we want to, now our goal is to make some configuration changes on those 100 VMs here. So so instead of doing them manually one by one, what we can do, we can go ahead and write a script by using the configuration management system, and that is what we can easily manage without having any kind of challenges. So this is what we define as a part of configuration management system. And then we have multiple tools that we have Chef, Puppet, Ansible. So let's suppose if we have a deployed LAMP stack server, so in those LAMP stack servers, we have to update the PHP version, we have to update MySQL, or we have to push a new application code. So we can do that easily by using these configuration management systems here. And that's why we have tools that we have Puppet. So Puppet is going to install Puppet Master, and Puppet Slave also needs to be deployed on the VMs that we are going to manage, that we are going to, we can perform the configuration changes on. So again, these VMs are going to have the Puppet Slave installed. So Puppet Master is simply, first of all, going to fetch the current configuration from Puppet Slave, and then it simply pushes the new changes, and then it simply asks for a confirmation if the changes have been applied or not. So that is what we define by using Puppet. And then we have the containerization platforms, that we have the app1, app2. So again, if we have multiple applications, so instead of sending them as a complete separate VM, we can go ahead and package them as a part of a single VM. So, and then as part of a single container, where we are going to package only the application and the bins and libraries required to run that application. And then we would be able to get the notifications, or we can say simply deployed. And if you want to attach it to any of the notification systems, we can easily do that. So here from the, basically Docker is created out of a Docker file, just like we create a template, and then from that Docker file, we created the image, and then from the image, we create the container that can be deployed as a part of any of the server environment. And then same way, we have the continuous monitoring, where we have to monitor multiple things, like we have where we can monitor all the access by different users, where we can monitor the actual, we can say, consumption of different resources. Here we can monitor if any instance is down for any reason, then we can see if they are down or not, and then we can choose to take up actions on top of it accordingly. So that is what we can define as a part of continuous monitoring. And then we have multiple tools for continuous monitoring, like we have Nagios, Splunk, Prometheus. Then we have Grafana support, Prometheus with Grafana support. We have multiple other solutions being deployed. All right, so as it's been almost time now, so let's do one thing. Let's say we wrap it up for today, everyone. And first of all, thank you so much for being a part of this entire session, everyone. Take care. Bye-bye.